SLA 3D printing. It offers an incredible accuracy with really highly detailed parts, whether for electronics enclosures down to small miniatures. One thing that I know that small and large shops really struggle to deal with is what their actual cost of fabrication is for SLA machines. Ultimately, we want to figure out what is a 1 liter worth of material worth to your business, and what should you ultimately price your customers for 3D printing services using your SLA 3D printer. Follow me and we'll figure this out together. So before we go into the 3D printing pricing calculator, what I'll have you do is go down to the link in the description below in the description, click on that link, open up the calculator so that you can follow me step by step, so you can enter in your own parameters that might be a little different than what I'm inputting, but I'm willing to bet that a vast majority of you will be right around the same inputs that I'm putting into this calculator. So go ahead, click on that link, and we'll go ahead and get started. Great, so now that we have the calculator open, we want to assume a few things. One, obviously this is an SLA 3D printer. Two, you're probably buying your material by the liter. So this might be from the original manufacturer, from a reseller, or from some sort of distributor. But the fact of the matter is that most of you are either going to buy this in bulk or you'll buy it on a per bottle basis. But in this example, we're going to go for a smaller desktop style SLA 3D printer. So keep that in mind as we go through all these other inputs. So looking at the calculator, I have it open in front of me here. I'm going to choose the purchase unit that I'm buying this material by the liter. So what I know in research from other different resellers and manufacturers, the average price of a bottle of white standard SLA resin goes anywhere between $90 a liter all the way up to $200, depending on who you're buying it from, what the quality is, etc. So we're going to go for kind of middle of the road, that's very typical out there, and we're going to assume $145 US for 1 liter of material. What we're also going to assume about this material is what you should do is look at the material data sheet of any material that you're going through and look at the density of the material when it's actually cured and when it's actually 3D printed. And what you'll find typical for this type of material is 1.12 grams per cubic centimeter is pretty much on the money for the density of this type of material. Next, we want to look at the machine cost, the lifetime hours of that machine, and the maintenance and service costs per year. For this example machine, we're going to go ahead and say it's $3,500 to purchase the machine, and that the machine itself has roughly 8,000 operational hours in its lifetime. So think about this for a second. It's not just about the usage of the machine, it's also how many times are you actually going to use this machine, its actual utilization over an annual period, and then forecast that into the future and say, okay, if it's X amount of years usage of this machine, you can reverse calculate that for how many actual lifetime hours that is until the machine depreciates down to 0, because that is a real cost, and you can measure this as you can see below here. If I have 8,000 operational hours of that machine, it's going to cost about 44 cents per hour. Now the maintenance and service cost, there's really two ways to look at this. A lot of people in the hobbyist community are do it themselves. They want to maintain the machine themselves, take it apart, do all those sorts of things. You really do need to compensate for your time for that. If you're not buying a service or maintenance package from the OEM or the manufacturer or reseller, you need to account for your time. So to do that, what are you charging per hour for other services, and calculate how many hours annually you're going into maintaining that machine. Usually, it actually comes out much easier if you pay the maintenance and service cost. You'd be surprised how much time or actual money that you save by buying these packages. It might seem like a large upfront cost, but it gives you security and peace of mind if anything were to actually go wrong with your machine, and could actually save you a lot of money and time in the future. So with all that said, let's look at the total machine time cost per hour. It's only 70 cents per hour, so we're looking pretty good here. Now let's look at the fabricated material. In our previous video, we took a look at FDM 3D printing and how you should price for that and general costs. Doing the calculation for SLA is a little bit more complex because we're dealing with not necessarily material deposition rate. We're basically trying to figure out what is our Z height per hour, essentially. How many layers per hour can we fabricate with this machine. In this example machine, and depending on which SLA machine you purchase, it might actually have a heat up time to basically get the resin into an ambient temperature for fabrication. This is really true for some of the larger industrial machines, might even be true for some of the other desktop ones that are recently coming out. So let's give ourselves also a buffer in here too when you send the file to the machine for it to process the file and getting ready for it actually to print. So let's just go ahead and assume here at the lower end, let's just assume 20 minutes to get the resin to ambient temperature before we're ready to 3D print and homing everything else. So this is a topic of debate here, looking at the layer print time per second. So there's a couple ways to do this. One is with the slicer, and I'll have a photo that pops up here in a second that'll basically show you the projected time in the slicer that it's going to take to produce a given object. And this varies wildly, of course, given your orientation of the part. If you're optimizing for time, you're going to be printing it with a lower Z height, right? However, if you print it more vertically, you will be having higher surface quality of the part more generally, but you might also increase the time to print. Regardless of how you orient the part, do this with one or a few objects, orient it in several different ways, go into that slicer, take the amount of time that it's going to take to fabricate that part, and then divide it by the number of layers. So you basically get layers per hour, essentially, or layers per second. So you can kind of reverse that, divided by 60, divided by 60, then you'll basically get your layer print time per second. And on a machine like this, typical desktop style machine, you'll actually get anywhere between 45 seconds to maybe a little over a minute, depending on several different factors about the part or the machine and print quality that you're going for. So in this example, let's actually shoot for 60 seconds, and we'll see where this gets us down the line. And we're also going to assume that we're printing at 0.1 millimeters for the layer height, which means, this is a very simple calculation for this example, that means 60 layers, layer print time in seconds, 60 seconds, times layer height 0.1 gives us 60 layers per hour, which means our Z height per hour is 6 millimeters. So putting all that together, that all makes sense. So looking at the next line here, the material and print time cost for 1 cube, what we're doing is we're taking a look at 1 cubic centimeter, little tiny cube, and that means if it takes, in the Z height, 10 or 20 millimeters or so, it'll take roughly X amount of time, and that all equates down to $1.32. And we'll move down in the calculation as we move along. So let's talk about the support equipment cost, which will include your cleaning station and the UV station as well to post-cure and wash. So typically you're going to buy this from the manufacturer, or you can build one on your own. But in this example, let's say we bought it from the manufacturer, which is about $1,200. And let's say that's going to be about 4 years usage out of both of those things, which will be an additional 15 cents for the depreciation per hour on that equipment. And again, you really want to calculate that part of your cost because it's all included in doing all of this. And then we look at the total cost to print 1 cube with all that added material, the depreciation costs and all of that is going to be $1.80 to print that 1 cube on that machine. Next, what we want to look at is the build area of the machine. And you'll notice that Z height is missing out of this. The reason why is because we can already calculate Z height per hour, how many layers per hour, how many millimeters per hour we can do. But we want to figure out what is the maximum area of any given layer that we're going to print. So what I'm doing here is I'm entering 145 by 145 millimeters. And what we're saying is that only 10% of that surface area is going to be taken up by the printed object's layer. Now imagine if you went any higher than this. Of course you can, depending on the build, so enter the value that makes most sense for your parts that you print, but you're really not going to go any more than 20%. I'm pretty confident about that, because if you did, imagine a huge part printed on an SLA machine and the peel force of that. Of course, there's newer model machines that are better at that, so you can increase the max packing density, but typically most machines have a peel force that go like this, or that just goes straight up and down. So you want to be careful of that. And depending on the style of machine, it can be higher or lower look at the recommended manufacturer's recommendation for that kind of calculation, but you can kind of be smart and look at your own parts and kind of do a rough estimation. If you want to do an exact estimation, you really can look at the cross section of the layers and calculate the actual amount of surface area per layer that those parts are taking up. So moving on from surface area and how much the max packing density should be for these parts, what we're going to assume in a 145 by 145 surface area and a max packing density of 10, we can say confidently that 21 1 cubic centimeter boxes can fit within that surface area, which means the print time to print those 21 is going to be 100 minutes. And then we get to assume, okay, we know what the density of the material is, we know how many boxes we can print. That means that it's going to be 23.55 grams printed in those boxes. And then grams printed per hour, since we're reversing that with 60 minutes, we get to say that the amount of material per hour is 14.13 grams per hour, and match that with the layer height of 0.1 millimeter and how many layers per hour, 60. So that kind of gives you kind of an approximation of how much material you can print within an hour and how long it'll take to print within an hour. Next, what's really important, and a lot of these next three factors are things that I see way too often small and large shops completely forget about entering these values into their costing model and ultimately how they should price for SLA. So let's look at monthly rent. There's two schools of thought here. One is to think about when a customer is basically ordering a part from you, they are renting not just your machine time, they are renting your business. So they're renting your office, they're renting all your utilities and everything else that goes into it. So if a client were to do that, they would basically have that part of their own costs, right? So you can look at it from that way. You can have the fully loaded rent and utilities cost part of this calculation. If you have multiple machines, you could do the same thing, but divide it by how many machines that you have. A third way is basically looking at the square footage of your 3D printers, or basically your whole area of where your machines are sitting, along with where your people kind of sit within your office, your team or yourself, calculate the price per square footage, and then add that into the monthly rent. And then for utilities, I've seen some calculators that look at the wattage of the machine and the usage. That gets really too far down it. Look at your internet costs, look at your heating bill, look at all the other things that are a monthly recurring charge. Take that average of the last 12 months. That'll do you just fine. You don't really need to get too complicated beyond that. So that brings us in this example. Let's just assume kind of a lower rent if we have only, let's say, one SLA machine, and we're going to do the fully loaded cost model for this for rent. We're going to say our rent's about $2,000 per month, and our utilities in a $2,000 per month office. I'm going to assume maybe $300 for that. So that brings us for the facility cost per hour for rent and utilities at $3.19. Okay, so moving on to the humans portion. So humans, obviously we mean your team, yourself, whoever is in charge of slicing the file, putting the files onto the machine, taking the parts off the machine, and ultimately handling that entire process. This might be multiple people, or it might be one. I'm willing to bet for an operation like this for a desktop machine, it'll be one person. They are putting it into their slicer, prepping it, and doing all that work. Now enter in what the hourly pay rate for a person that's running this operation is getting paid at. So let's just assume in this example, $40 per hour. Might be high, might be low. Enter what value makes most sense for you. And we're going to say that this is typically going to take 30 minutes to set up a print job using SLA. This includes, again, preparing the file, putting it in the slicer, orienting it, taking the part out, support removal, all those good things. So that comes out to, for every one print job, if it takes 30 minutes, it'll take $20 worth of setup and teardown cost per print job. Now the thing that practically I've talked to so many different shops, everybody seems to forget this step. It's kind of crazy. Like, look at all the software that you use. One, you hopefully we'll come to an understanding that the software that you're using is critical to your operation, but also include this part of your costing model for your business and what you ultimately price for your service. So if you're using the typical industry standard CAD making solid modeling program, you're probably paying $4,000 a seat. There might be a maintenance cost to that. Annualize it and include it in that line. For your CAM and your slicer, you could be using many different things, or your ERP system. Look at all your other different softwares that you use for your Gmail, for your website builder. All those other things that go into running your business, again, are for the purpose of you offering services in the first place, right? So you should include them as costs. Now, taking all of these into account, and a quick plug for MakerOS, if you were to take some of your basically your ERP services and all the other softwares that you're using to try to solve not just pricing but project management, calculate that in there and enter in what level of MakerOS fits best for your business, and then you'll see kind of the cost savings there per hour just on purely a cost perspective. Then we'll talk about value in a moment. So in this example, this is very typical for a shop like this, is to basically have $8,400 annually in software costs, which equates to about $4.04 per hour. So as I'm doing this, you're probably looking at the right-hand side of the calculator on the calculated cost per hour. For some people, this is gonna scare them. Don't be scared. This is actually pretty typical. This is normal, and we're gonna find out a way how to make up for your hourly cost. So if we look at all of those things on the right-hand side, and we figure that our total hourly cost is $9.40, let's figure out, when we bring this back from the very beginning, what does it actually cost to fabricate 1 liter of SLA material? So let's bring it here for a second, and I'm gonna zero this one out. The cost to fabricate, the cost of fabrication of that 1 liter of material is $691.85. Now this might, again, scare a few others. Again, this is calculated by how many hours it's going to take to fabricate that 1 liter of material, which in here we're saying about 73.61 hours, right? Because we did that whole calculation in the fabricated material tab. So if we're basically saying that our grams per hour is 14.13, and we divide 1,040 by that and how many hours it takes to fabricate all of this, it'll be 73.61 hours. Multiply that number by the $9.40 gets you the $691.85. But we're not done yet. We have to figure out how many print jobs is typical for 1 liter of material. And again, this will vary wildly for the types of parts that you're printing and how dense you pack your machine. The best way to go about this is to either physically measure your past 10 jobs with the support material in it. So take those past 10 jobs, weigh them, how many grams were they? And then you can say, okay, if each is about 1,000 or 100 grams to build a typical print job with that machine, then that means you can get approximately 10 jobs out of that 1 liter of material, right? So let's use that as an example. If we're printing kind of small to medium parts, we can say, 10 jobs here. So we take the 10 jobs multiplied by the human cost, which is $20 per print job, is an additional $200, which brings a grand total cost to fabricate that 1 liter of material at $894.17. It seems like a lot, but again, that is very typical. I want to be really reassuring here. This is very, very normal. So let's figure out what should we charge, and let's get kind of philosophical here for a second about the pricing structure and everything. So let me zero this out and let's look at your break-even costs. So we already know that the total cost to fabricate is $894. So the cost per gram is 86, and it's 96 cents per cubic centimeter, or $12.15 per hour. Now think about that for a second. If you are pricing, given these parameters, below $12.15 per hour, or below the grams or cubic centimeter price, you're losing money. So how do we make money? Let's think of it in a couple of different ways. One, let's assume that you're a smaller shop. You are consultative with your clients, so you're adding much more value beyond the print itself. If the client were to do this themselves, how much time, energy, expertise, and years of training would they need in order to execute on this part? The third thing too is to look out into the market, what are competitors pricing? And what you'll find time and time again, there really is no standard in pricing for SLA, FDM, or any other process. Small and large pricing ranges wildly, and again, the biggest reason why is because no business is the same in a lot of their costing structures or even the value that they add. So I am of the perspective, and I am of the thought that a business should be really hands-on with their clients to add more value beyond the fabricated part. You're helping to guide them to the right solution and to be very application-oriented with them. So with that, it's really not out of the realm to price even more than about 200% margin for printing an SLA like this. Because think about it, pricing in this range for a very high quality part that can sometimes outcompete FDM or even SLS, depending on what the application is, you are really in the sweet spot at this level that I'm suggesting to price at, basically to provide the high quality, high tolerance, high touch point type of service that you can be. And this is really attainable. Do not be afraid to price a little higher than maybe what you're used to. And another thing too is that it's much easier to come down in price than it is to increase price after the fact, especially if you're doing high volume type of printing and you have a whole bunch of clients. But if you're working for clients that do more engineering type of projects that need that high quality, they're going to appreciate the level of service and the level of quality that you're able to provide for them. So do not be shy from a price point like this. So let's take a step back for a second and let's look at what we just did. What we just did are two things. We figured out what it costs to fabricate 1 liter of material for your SLA machine, and that number is $894.17. Given all those things I mentioned about markup and value, we can have a 200% markup, which means that the output that you can have, what is the actual value of that 1 liter of material, is actually $2,682.51. That is the value of that 1 liter of material. So let that sink in for, again, one more second. I know it may seem like a lot, but again, that breaks down into the cost per gram, cubic centimeter, and price per hour. So let's look at one scenario. Let's say a client orders a small part that's only going to be a few millimeters in height. What should you charge for that, for let's say a 1-hour print, given everything that we mentioned above? What we're looking at is the total hourly cost from above is $9.40. The added human time for that print job is $20, and then your markup of 200%, which means $93.60 for a 1-hour print. Now you can carry that forward and project that into longer prints, and that can be a really good basis for how you price for your SLA machine. Now, one more thing before we leave this calculator, and I hope you learned a lot about the pricing and value structure for SLA 3D printing. Obviously, depending on different geometries, different types of parts, and different machines, there are so many different factors that go into pricing, right? So the great thing, not only about our calculator, but about our product and our platform, MakerOS, is that it takes all of that into account. It takes into account the bounding box of the object, and it takes into different attributes of the actual part itself, including the bounding box to volume ratio, which are really important in dialing in the pricing algorithm. We also have the ability to change the algorithm depending on those attributes as well. So you can step down pricing depending on the printed volume of the object, and then you can step up pricing depending on the bounding box of the object. So you don't have to worry about those, really large bounding box objects that are low volume, like an architectural model or a gyroid. So you can be really spot on with your pricing methodology. And what's even better than that is, beyond the quoting, you're in the business of actually completing projects. You're not in the business of providing quotes. So if you can ingest clients to give them a basis to get a quick quote and then service them way more after the fact, you can add other services, including CAD, design, and different types of 3D scanning services, part cleanup. You name it, you can offer it as a service with our platform. And it's extremely easy to install on your website and to white label and to custom brand it however you want. So if you enjoyed this video, if you learned something, please let us know in the comments. and please reach out to us by going to MakerOS.com, and you can get a custom one-on-one session with me or any member of my team so that we can walk you through not just the calculator, but also run through a demo of MakerOS and how it best fits for your business. Well, thank you very much. I enjoyed this. I'm always a huge nerd when it comes to not just pricing, but the machines themselves. So I really look forward to producing the next set of videos, which will talk about SLS and a bunch of other different types of 3D printing methodologies. So thank you very much, and I'll talk to you next time. See you later.